In this video, I will go over AP Calculus topic 7.1, which is modeling situations with differential equations. So first, a differential equation. A differential equation is an equation that has functions and its derivatives in the same problem. So kind of some examples with some notation. You can use our prime notation. We can use our function with the prime notation. We can use our dy dx or d2y over dx2 notation. So a reminder from probably Algebra 2 is where you first saw this. Direct variation and inverse variation. So direct variation, if y varies directly with x or y is proportional to x, then y equals kx, where k is the constant of proportionality. Inverse variation, however, if y varies inversely with x, then y equals k over x. So we're going to look at a couple situations, and we are going to write a differential equation. So these are all going to involve some sort of rate of change. So in my first example, the rate of change of a function b with respect to time is directly proportional to the square root of b. Write a differential equation that models this situation. So the rate of change is going to be our derivative, and it's the rate of change of b with respect to time. So we're going to write that as db dt, and we're saying that is directly proportional to the square root of b. So I'm going to put that constant of proportionality and kb. So this says that the rate of change of b with respect to t is directly proportional to the square root of b. Newton's law of cooling says that the rate of change of temperature T with respect to time little t of an object is proportional to the difference between the temperature of the object and the surrounding temperature. If an object is placed in a freezer that is 5 degrees, what is a differential equation that will model this situation? So dt is going to equal k times the difference between the temperature and the surrounding temperature. So that's going to be T minus 5. Next, the rate of change of h with respect to time is inversely proportional to the square of h. Write a differential equation that models this situation. So we're going to have dh dt. We can have all sorts of variables, but often in real-world context we use time. Is inversely proportional. So the k is going to go on top, and the square of h. So there's h squared. So inversely proportional, we're going to get that fraction there. And then for the increase in in the volume of water in a container V is directly proportional to the product of time t and the volume of water. At time t equals 2, the volume of water is 25 centimeters cubed and increasing at a rate of 50 centimeters cubed per minute. Write an equation to model this situation. All right, so let's start from the beginning. The increase, so that's our rate of change of volume in the water V. So dV dt is directly proportional to the product of time and the volume. Okay, so here you have an equation where we've got multiple variables. Both t and v are variables. K is our constant. In this case, we have enough information to actually find our constant. So it says at time t equals 2, the volume of the water is 25 centimeters cubed and increasing at a rate of 50 centimeters cubed. So my rate is going to be 50. K is what we're solving for. Time is 2. And the volume is 25. Sorry, I have a typo. I meant this to be 2.5. So this is going to be 2.5 here. So we have 50 equals 5 times k. So my k is 10. So my final differential equation is going to be dv dt equals 10 TV. So this is your introduction to differential equations and how we can set up equations to model different situations.